I want to welcome you to the first of a few algebra review sessions. This is my first time really doing it live, but I figured it's something I want to do a little more often. We're going to start with first just telling you a little bit about myself. My name is Mrs. Washington. I've been teaching since 2005 um, at Valencia College, Miami-Dade College, and Oak Ridge High School. I have been working for myself the last 3 years, helping people like you accomplish their goals. Um, and this is just my way of providing my service to you for free as a gift, just because I'm thankful that I'm able to do something that makes me happy. Um, Second thing I wanted to talk about was who this is for. This can be for people in like an advanced pre-algebra class in 7th and 8th grade. This can be high school algebra 1, freshman year, 8th grade year, some 7th graders even. If you're reviewing for the PERT as a dual enrollment, if you just need to brush up on your math in general, this does cover a lot of areas depending on what your needs may be.
I'm not sure I understand.
Not Siri. Let's take the third thing is that what I hope for you to gain from this. Number one, I want you to gain some confidence. Math seems to be a hurdle that a lot of people choose not to cross because they believe they can't do it. But math has a lot of the more financially abundant careers out there. And frankly, I just feel like America needs to catch up. Secondly, I want to clarify common misconceptions that I've seen in the last 16 years teaching in the classroom. These little misconceptions tend to like haunt you and follow you throughout your math courses. So if you get them straightened out, it usually works out well for you. And so today, what I'm going to talk about is signed numbers and order of operations, as well as the difference between expressions and equations. This is pretty much the foundation or the basis of algebra, geometry, and even higher level math, okay? So first thing I'm gonna do is share a whiteboard and put up an example. So I'm gonna start by saying, okay, so first things first, we have to kind of understand how positive and negative numbers work. Seems to be something that most people struggle with if they're struggling with this topic. So let's go for a basis. So first of all, everything in math is usually always split into two groups. We have what do I do when I add and subtract? And what do I do when I multiply and divide? Okay. And so everything kind of always gets put in those two groups. So for example, I'm going to put a couple of different problems up. Okay, so here, let's start with the adding and subtracting. Okay, so first thing I want you to know is when it comes to adding and subtracting is really like you're grouping like things together. Okay, so this number here has this sign in front of it. This number here has this sign in front of it. So technically this is a -5. This is a -7. So that means I have 5 negative. That's 5. And then I have 7 more. So how many negatives do I have in all? And that would be 12. So basically, I like to call them good guys and bad guys. The good guys are the positive guys, the bad guys are the negatives. And in this case, I had two groups of bad guys. So I have a very big group of bad guys. When it comes to this one, if you look at the second one, this time I have 5 bad guys and I have 7 good guys. Okay, now they die, they die, they die, they die, they die, and what's left? 2 good guys. Okay, now this is where you usually hear your math teacher say, oh, if you have one of each, you're going to subtract and take the sign of the highest number. Well, here you go. 7 is bigger than 5. It's positive. That's why my answer is positive. Okay, so when it comes to adding and subtracting, it's about who wins, like tug of war. Okay, or I declare war. And this third one here, you see there's 5 good guys, but there's 7 bad guys. So when they start canceling each other out, what happens? There's 2 bad guys. Okay, again, I'm subtracting them and taking the sign of the biggest number. Now, when it comes to multiplication and division, how I like to think about it is, or what I teach some of my students, they can jot this down on scrap paper, like before they take a test, especially if you're not allowed to use a calculator, it depends. I think everybody knows the game tic-tac-toe. So you know tic-tac-toe, you win when you get down the middle. So P stands for positive. Okay, and we're gonna put N's everywhere else. So N stands for negative. So what I'm gonna do is just use this as a guide to confirm the sign of my answer. So for example, this is -5 times a +7. So if I look over here, a negative times a positive is a negative. It works all the directions. A negative times a positive is a negative. So I know my answer here is going to be -35. Now, when I look at the second one, here I have a positive times a negative. So I'm going to come over here. A positive times a negative is a negative. I can do it another way. A positive times a negative is a negative. So I also know that this one is going to be -35. So last but not least, I have -5 times -7. So you see here I have a negative times a negative is a positive. Negative times a negative is a positive. Negative times a negative is a positive. It doesn't matter. Doesn't matter which way you do it, it works. So this one is going to be a +35. So now what usually causes students problems is putting it all together, right? Because our problems are usually longer. They usually have addition, subtraction, multiplication, division, sometimes parentheses, sometimes exponents. And that's when we get into the order of operations. So let's pull up some of those. Okay, so let me see. I have a couple problems here that I have from the thousands of books that I own. Let's see, that's too easy. Too easy. Okay, here goes some. We'll start off with the easy one. I'll change my pen to black and okay, so let's see, let's start with this. 16 divided by 2 to the third power plus 3 minus 2. Now, if you're watching the video or the playback of this, I want you to go ahead and pause it, try it, and then watch for the solution, okay? It's the easiest way for you to learn, show how you work so you can really document the step that you may have messed up. Okay, so order of operations tell me I'm gonna do parentheses or all grouping symbols. A lot of people kind of, this could be absolute value, which are the straight bars. This could be like, the braces. It could be regular parentheses. It could be brackets. It could be any of these. These are all grouping symbols. So they all go first, okay? A lot of people don't talk about it. So please, I'm going to say parentheses because that's what, actually, I'm going to keep it as grouping symbols because that's what's accurate. This is a grouping symbol. And we just talked about what that was. Okay. All right. E we know stands for exponents. Now, I like to write multiplication and division next to each other because they are equal. Multiplication does not always come before division like a lot of people have been taught. It depends on which one comes first. As you read the problem from left to right, just like a book. When you read a book, you start on the left side of the page. And as you read, you go to the right. When you get to the end, what do? You go back to the left and you read it again. That's exactly how you should be reading your math problems, okay? So if the division comes before the multiplication, as you read it from left to right, you would actually do that first. So I'm gonna make sure I do an example like that. Next is gonna be addition and subtraction, which again, they're like equal. When you get to the end, those should be the only two operations left. And at that point, you're just combining the good guys and the bad guys, okay? So here, there are no grouping symbols, but there is a parentheses, an exponent. So 2 to the third power. The mistake a lot of people make is they say 6 because their brain naturally puts the 2 and the 3 together for 6. But really, this is 2 times 2 times 2. So do yourself a favor, even if you're very good at math, and just write it out, okay? And I'm one of those people that I like to do one thing, bring everything down so you don't mess it up, okay? So next, when I go left to right, I got division. So 16 divided by 8 is 2. So notice that the only thing left here is addition and subtraction. So I got the 5 minus the 2, which is the 3, okay? All right, so let me pick another one where the division, oh, here we go. This is a good one. So let me erase this. All right, so let's say okay. Let's say, so this is example number 2, technically. So we have 30 divided by 6 plus little braces 4 divided by 2 times 3 minus brackets 3 plus 5 minus 4. Boom, boom, boom. Okay. There's a lot going on. So here, notice that I have more than one set of grouping symbols. So notice here that I have more than one set of grouping symbols. So what you always want to do, you want to find the innermost set. So here I have the braces, but then I see I have the brackets, but inside those, I see that I have parentheses. So I'm actually going to start in there first, okay? And in there, all I have is subtraction. So 5 minus 4 is 1. So yes, I am going to bring everything else down because that is how I like to do it. And so it's going to be just 3 plus 1 basically. Okay, so notice the parentheses are gone. Okay, but I still have the braces and the brackets. So I'm going to go in here first. 3 plus 1 is 4. So again, I'm going to write everything down. Make sure you don't change the problem. And I'm not going to write those symbols anymore. I'm just going to do -4. Okay, so now here's where people usually mess up. So right here, as I read the problem from left to right, division comes first. So 4 divided by 2 is 2. I'm going to bring everything else down. I'm not trying to mess nothing up. Actually, I see also I have from left to right 30 divided by 6. So I'm going to go ahead and put a 5 for that. Okay, so 5 plus. So in here again, I got 2 times 3, 6. So I got 5 plus 6 minus 4. And we're just going to finish it out. We got, change my color one more time. 6 minus 4 is 2. So 5 plus 2 is 7. So that was kind of a long, exaggerated one, but it had a lot of good things. It had multiple grouping symbols. It also had the division before the multiplication. So I really like that one. Let's see here. Do a couple more. Okay, here goes another good one. So this will be example number 3. Okay, so this one is 12 divided by 4 times 2 plus 2, 5 minus 3 minus 3 times 4. Okay, so same thing, I'm going to work the problem from left to right. And from left to right, I see this division comes before this multiplication. So 12 divided by 4 is 3. Bring everything else down. I'm also going to go ahead and work these parentheses. 5 minus 3 is 2. Going to go right back to reading the problem left to right. Got this multiplication. I got another multiplication, another multiplication. So 6 plus 4 minus 12. And then 10 minus 12 is a negative 2. Okay. All right. Let's see if I got any more that I gotta do. Okay. So that is just a pretty brief understanding of, positive and negative numbers and the order of operations. Obviously, they're not always whole numbers. Sometimes they could be fractions. Sometimes they can be decimals. And if you get confused with those, that just means you need help understanding how to add, subtract, multiply, and divide fractions and decimals. I always like to tell students, the better you know your multiplication tables, the easier the fractions are. They're not as bad as you think. It really is how well you know your multiplication. But the order of operations doesn't change. The positive and negative doesn't change. All that stuff still applies no matter what. So the next thing we're going to do is we are going to talk about the difference between expressions and equations. It's a super common misconception or just like lack of understanding that I notice with students. So we're going to talk about that next. Expressions. Okay, So first things first, make this a little bigger. Yep. Okay. Click it. There we go. Okay, so here we go. Let's just say, let's talk about what's the main difference between these two things. Okay, so let's say I have, we'll draw a line in the middle like we did before. Let's say I have something like -2 3x minus 4 plus 7. And then over here, say I have minus 8 equals 12. Okay, so when you look at these two, when you look at the left side and the right side, okay, what's the main difference you see between what I have here? They almost look exactly the same, right? Except on the left side, there's no equal sign, and on the right side, there is. And that right there is one major difference, and it actually should like trigger you to respond in a certain way. Okay, so simply put, when you have an expression like no equal sign, right? So I'm going to write that here. No equal sign. The only thing that you can do is simplify. Okay, the only thing that you can do is simplify. Now, a lot of times people are like, well, what does that really mean? Like, well, I never know when to stop simplifying or something like that. So I like to summarize simplifying into like 3 major things. One, it could be combining like terms. Okay, that means like 2x plus 3x is 5x. That could be simplifying. Something else that could be simplifying would be distributing. Okay, let's talk about what that looks like. Distributing. Let me get my pen back. Now, what does that look like? Distributing looks like right here. -2 to 3x and -2 to the -4. Distributing is just like multiplying. Okay. And one more thing that usually involves simplifying is, and I'm sure you guys love this, it is reducing fractions. Okay, your fraction should always be reduced. Always, always. You cannot say you're done unless that fraction is reduced. Okay, so now when it comes to the right side of the screen, over here there is an equal sign, and here not only can you simplify, so not only can you do everything that was on the left side, but you can also solve. And what does solve mean? Solve means get the letter alone. Okay, get the letter alone. Okay, and how do we get the letter alone? Opposite operation. So we'll talk about that in a second. Okay, so expressions, no equal sign. Equations have an equal sign. Expressions, the only thing you can do is simplify. Equations, you can simplify and you can solve. Okay, so we're going to work on this left-hand side. We're going to simplify it simply by distributing and combining like terms. So here we get a -6x plus 8. I'm bringing down the plus 7. Okay, so again, simplifying not only means to distribute, but it also means to combine like terms. And the 8 and the 7 are regular old numbers. That means they're like terms. So -6x plus 15. Notice that my answer is like this whole thing. It's a binomial. It has two terms, okay? You can't solve this. All you can do is simplify as much as possible. But on the right-hand side, we're gonna take it a step further. We're gonna distribute first, bring everything else down, okay? And I'm gonna combine like terms. This time, my two numbers, positive 8 and negative 8, disappear and cancel each other out. So I'm left with negative 6x equals 12. So this is where you have to know how to solve. So the equal sign is like a bridge, okay? I want to get this guy by himself, which means this negative 6 has to cross the bridge. The only way he can cross the bridge is if we do the opposite of what is currently happening to him. So since negative 6 is multiplying by x, the opposite of multiplication is division. So I need to divide by negative 6. Now notice I'm not changing the sign. So I'm not saying opposite number, opposite operation. Okay, multiplication, division. And whatever you do on one side, you have to do on the other. So I have a positive x, I have a positive divided by a negative, which means I'm going to get a negative 2. So notice my answer for the equation is some letter equals some number. I have solved this. I have an exact answer. Okay, expression, numerical answer. Okay. All right, now let's focus, let's do a couple just expressions, just simplifying expressions, okay? Let's see here. Okay. Okay, I like this one. Okay, so let's focus on the first one. So I always like to put one up like this because a lot of times when students see these parentheses, you know, they kind of knee jerk to order of operations, like, oh, I gotta go there first. But there's like nothing to do. Like these are not like terms, they don't go together, they don't match. And in between the two sets of parentheses is this plus sign. So really I'm just adding everything together. I don't even need all this. Like this is just extra. Oh, I need that 7 though. I need that 7. We put that 7 back. Okay. Okay, so now when I look, I'm just looking for things that match, like terms, okay? Like terms have to have the same variable as well as the same exponent, okay? So when I look at this, I'm like, all right, well, negative 9 and positive 7, those guys go together. So we got negative 2 left of that. And then 8AB and negative 2AB, those guys match as well. So that's going to be 6AB. So 6AB minus 2. That's as simplified as it can go. They don't go together. They're not like terms. You're done. Okay, next one. I'm looking. I'm like, okay, 8x. This guy needs to get distributed. And believe it or not, this negative is really like a negative 1. So I need to go ahead and distribute that as well so I can get rid of all these parentheses. Okay, so the 8x is going to come down. This is going to be minus 3x minus 3y minus x plus y. Notice I didn't write any parentheses because since I distributed, the parentheses are gone. So now what matches? 8x minus 3x minus x. So I get a 5x right here minus x. So I end up with a 4x. And then I have minus 3y plus y. So minus 2y. Again, both my answers were expressions. They're not like terms. I can't simplify them anymore. I can't distribute. I can't combine like terms. There's no fractions to reduce. That's it. Okay. So now let's look at a couple equations. And then that'll be it for today. Let's see here. Okay, let's start off with something basic. So again, this is solving equations. The previous area was simplifying expressions. Okay, so let's see, we got 3x plus 5 minus 2x plus 1 equals 6x plus 4 minus 6x. Okay, so remember when I first started talking about this, I mentioned that when it comes to equations, I can do both simplifying and solving, and you have to do both. In order to solve, you must simplify first, okay? So on the left-hand side, I just want to see, is there anything I can reduce down? And same thing on the right, is there anything I can reduce down? Okay, so I can see 3x minus 2x is just regular x, positive 5, positive 1, I got a plus 6. So that's much smaller already. And then I also noticed that positive 6x and negative 6x cancel, so I'm left with just a 4. Boom, easy. So there, now there's only one thing left for me to do to get this letter by itself. Since it has a 6 being added to it, the opposite of adding is subtracting. And whatever you do on one side, you have to do on the other, okay? Again, notice my answer is x equals some number. I'm actually solving. I'm getting the variable on one side by itself and everything else on the other side. And 10. Here goes some. Okay, here goes another one. Okay. 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 So here we have an equation. Again, I need to simplify as much as possible in order to solve. So that means that I'm going to distribute the 5 first. 5x plus 10. Bring down my equal sign. Distribute the 3. 3x plus 9. Bring down my plus 1. Always look to see, is there anything else I can make smaller? For sure, 5x plus 10 equals 3x plus 10. So what happens here is when I try to move this positive 10 to the other side, it actually makes them both cancel out. So what we're left with here is an untrue statement, okay? But we're gonna finish it out anyway. So here we go. I'm gonna subtract 3x because I'm like, I wanna get all of them together. So technically I have 2x equals 0, like, right? Because this canceled out, nothing's there. The last thing I need to do to get x by itself is divide. It just so happens that when I do 0 divided by 2, my answer is 0. Okay, so if you ever get stuck with variables on both sides, your job is to just get all the variables together on one side. It's not up to you to determine if the answer is 0 or undefined or no solution or any of those things. Let's look at another one. Okay, y minus 4 minus 2y equals 7y minus 1. Okay, we're going to handle it pretty similar to the way we did before. We're going to distribute wherever necessary to get rid of the parentheses. On the left-hand side, I'm distributing a -1. So I get y minus 4 plus 2y, that's an ugly 4, equals 7y minus 7. I'm going to combine wherever possible. Y and 2y is 3y minus 4 equals 7y minus 7. Again, we got to get all the letters on one side and all the numbers on the other. So I'm going to subtract the 7y, so they're together. So I have negative 4y minus 4 equals -7. I'm going to plus the 4 to get all the numbers together. Negative 4y equals -3. And the last step to get y by itself is to divide by -4. So yes, my answer is a fraction. I do need to simplify this though, because a negative divided by a negative is a positive. So that would be my final answer. I don't want to make this video too long. So I will do another video with harder expressions and equations, with more fractions and things like that, more exponents, but this is the basis of everything that we do in algebra. I just want to say thank you for joining me. Thank you for watching my video. If you have any questions, don't hesitate to reach out. You can email me. I'm also going to have a Telegram group chat just for algebra students to ask me questions, and I will answer them back live. Okay, so thank you so much for joining me. It's been a pleasure. I really do enjoy this, and I hope to see you soon.